Math 113 5-6 lesson covers graphs of other trig functions. So 5-5 covered sine and cosine. So we are now going to cover tangent, cotangent, secant, and cosecant. So I will tell you this, if you have not yet completed the assignment for 5-5, you should turn this video off and make sure that you're able to complete sine and cosine first. It is going to be imperative that you can do sine and cosine in order to do cosecant and secant. So turn the video off, go finish 5-5 if you have not already done that, and then come back to this video. Okay, so let's get started. We will start with y is equal to the tangent of x. A few things that are going to be a little different this time. When we start our table, we are still going to use values that are on the unit circle, but I'm not going to start at 0. I'm going to start at -pi/2. And I am going to count by pi/4. And you will see why once we get to graphing tangents. Okay, so we are talking about the unit circle. So let me just sketch a little unit circle here. We've got these values x and y on the unit circle. Okay, and so just for a little quick review, remember tangent tangent of theta is equal to y/x, the ordered pairs. Okay, so if we're doing the tangent of -pi/2, first of all, you've got to know where that is located. -pi/2 would be right here. Okay, so the ordered pair 0, -1. So at 0, -1, when I take y and I put it over x, I end up with -1/0, which is undefined. You cannot have 0 in the denominator. That means that at -pi/2, there is an asymptote. All right, let's go on to pi/4. -pi/4. All right, -pi/4 is not quite as far. It is right here. And the ordered pair there, or you could do the hand trick, all right? And when we figure out the tangent at -pi/4, it is -1. At 0, we would get 0, pi/4, 1. And again, when you get to pi/2, that ordered pair, you would get 1/0, which again is undefined. Okay? So if you're struggling with the -pi/4 and the pi/4 because you don't see those ordered pairs, then jump to the hand trick to help you figure out the tangent at pi/4. All right, so now let's graph tangent using these values. All right, -pi/2, -pi/4, pi/4, pi/2. So those are my 5 key points that I'm going to use. My maximum is 1 and my minimum is -1. All right, I will graph tangent in whatever this color, pink. Okay, at -pi/2, I told you there was an asymptote. Okay, a vertical asymptote. Okay, so it doesn't ever actually touch that value. At -pi/4, it's at -1. All right, at 0, 0. And then at pi/4, +1, and then we have another asymptote at +pi/2. Now, when we graph this, that is not a straight line. And so some of you are going to try to make that a straight line. That is not a straight line. And so this is a curve, and my curve gets really close to the asymptote. All right, as close as it can get, it gets as close to the asymptote. So it's a curve. I don't really like my curve that I just drew for you, so I'm going to try one more time. I just don't like the way that curve looked. Put some of my stuff back on here. All right, so really close to the asymptote. All right, good enough, good enough. It is not a straight line. I needed you to see that it is a curve. All right, it is a curve. So this would be one cycle of the tangent function. And so the period here is not 2 pi, the period here is pi. So let's talk about some important things about our tangent function. The period is pi, that is super important. All right, we're going to use that as we go. The domain, oh, it's a little confusing. Okay, it keeps going left and right because the tangent curve does continue just like this, but it'll keep having asymptotes. And so notice it has an asymptote at negative pi over 2, at positive pi over 2, okay? So here's what's going to happen. It is going to have, the domain is going to be values that are in the x values. That will be all real numbers. Okay, now we've got to exclude our little asymptotes, except odd multiples of pi. Except odd multiples of pi. Over 2. Sorry, that should say pi over 2. Odd multiples of pi over 2. Okay, our range would be another important value. And our range, there is no asymptote. And so our range is up and down, y values, and it is all real numbers. So another super important idea about tangent is you're always going to have asymptotes, okay? And they're always going to be vertical asymptotes. So we always have vertical asymptotes. And on this original one, my vertical asymptotes are at those odd multiples of pi over 2. That's where they are. Like 1 pi over 2, 3 pi over 2, 5 pi over 2, the odd multiples. Okay? And then the last thing that I want us to remember is that we have x-intercepts, and those are located midway between the asymptotes. And so that's going to be helpful when we start creating some tables. Okay, the x-intercepts are midway between the asymptotes. So if we look at this diagram for tangent, asymptote at negative pi over 2, and at pi over 2, there's an x-intercept at 0, which is in the middle of those two, midway between those two. All right, now just like sine and cosine, we can have an A, B, C value. We could have a D, but boy, that is a dirty little trick when they go putting a D. So I don't think we actually are going to have a D value. It gets a little confusing. So let's just review. Again, you should have already completed section 5. So our A, B, and C are similar, okay? My A value is still my amplitude. The absolute value of A is still my amplitude. And then I figure out where are my asymptotes. All right, so I've got to know where they are. Here's how you decide where your asymptotes are. They are at bx minus c equals negative pi over 2, and they are at bx minus c equals positive pi over 2. These are the two original asymptotes. All right, and so that's why we decide to use that. All right, and so those are the things that are super important there for you to decide. We could also do our period. Now, the original period for tangent is pi, so you're going to divide it by the b value to find out what your period is. All right? There we go. So let's actually try a problem that has some of this. Whoops. All right, let's have an a value, and for now, let's just have a b value. And so we are going to graph this function for x values from negative pi over 4 to positive pi over 3 pi over 4. So it's telling you what it wants your x values to become. All right, it's telling you that. All right, so here we go. Our amplitude is the absolute value of 3, which is 3. Awesome. Now we need to do our asymptotes. All right, so my asymptotes for this particular problem, my bx minus c is just bx. So 2x is going to be equal to negative pi over 2, and 2x is going to be equal pi over 2. Solve each one of these for x, and we'll know where our asymptotes are going to be located. So negative pi over 2 divided by 2 is the same thing as times a half. So our first asymptote will be at negative pi over 4. To move this 2 away from x, I multiply by 1/2. So pi over 2 times a half is x equals pi over 4. So these are asymptotes at negative pi over 4 and pi over 4. All right? There we go. And so now we need to know, we know that there is an x-intercept between those. Okay, so I'm going to write that down. My x-intercept is going to happen at x equals 0, because that is what's between negative pi over 4 and pi over 4. That's the middle of those two. All right, so now I'm semi-ready to do a graph. So let's go ahead and try to put what we have on a graph. All right, so I know I've got an asymptote at negative pi over 4. I know I've got another asymptote at positive pi over 4. I know I have an x-intercept at x equals 0. Those are the things I do know, without a doubt. All right, so now if I'm thinking about my table, like what values do I use? Well, I have to know a value that goes between those two and that goes between those two. And so it's halfway. So halfway between 0 and pi over 4 would be pi over 4 times a half, which would be pi over 8. Okay? Pi over 4 times a half. So I get pi over 8 here. That's what we're counting by. It's pi over 8. Now we're ready. Now for those of you that are like, oh my gosh, Ms. Work, show the table. Okay, I'll show the table. Negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4. Now my y values for tangent, okay, we know that this one is undefined, it's an asymptote. We know this one's undefined, it's an asymptote. We have an x-intercept in the middle, so my y value is 0. And then my amplitude helps me decide what is the y value at negative pi over 8 and pi over 8. And since my amplitude was 3, then that would be those two. I think I wrote them backwards. This one should be the negative. And this one should be the positive. All right, because typically in tangent it goes undefined, -1, 0, 1, and undefined. So the only thing that changes here is that our amplitude is 3, so it has to go up to 3 and down to -3. Now we're ready to graph. So 1, 2, 3. 1, 2, 3. All right, I will graph my tangent in green. All right, I already have an asymptote at pi over 4. Negative. At negative pi over 8, I go down to -3. I have an x-intercept. At pi over 8, I go to positive 3. So when I graph this, I make sure it looks like a curve, not a straight line. Now, I know it's only slightly curved, but it is a curve. So there is one graph, one cycle. Now, if we pay attention to my directions said, hey, I want you to go all the way out to 3 pi over 4. Well, it repeats itself. So let's keep going. All right, essentially we've got pi over 8, 2 pi over 8, 3 pi over 8. 4 pi over 8 is actually pi over 2, 5 pi over 8, and then 6 pi over 8 is really 3 pi over 4. So we would have another asymptote over here. That should have been a 4, not an 8, sorry. I said 4. Okay, 6 pi over 8 simplifies to 3 pi over 4. So I have another asymptote at 3 pi over 4. Right in the middle of that, I'm going to have an x-intercept. Okay, remember I said that it repeats. So we would be at -3 here, we would be at +3 at 5 over 8, and so now we just draw our curve. There we go. So now we have graphed all the way from -pi over 4 to 3 pi over 4. So this is 2 full periods of tangent. 2 full periods of tangent. All right. Let's move on to cosecant. Actually, let's go on to cotangent before we go to cosecant. All right, so cotangent of x, we know, is the reciprocal of y equals the tangent of x. So here's why that's helpful for me. So everywhere that tangent of x crosses the x-axis, that means the y value will be 0. Cotangent of x would have an asymptote. Okay, everywhere that tangent crosses the x-axis, cotangent would have an asymptote, because that would, it's the reciprocal, so it would put a 0 in the denominator, which cannot happen. So if I look at my graph, let's say I go just like on my tangent. I went -pi over 4, -pi over 2, 0, pi over 4, pi over 2. Now, when we did our original tangent, this is where I stopped. Okay, for our original tangent, we went up to 1, down to -1. Okay, so tangent crossed the x-axis at the y-axis, right? So there is an asymptote at the y-axis for cotangent, because for tangent, that's where it crossed the x-axis, all right? Now, at where would the next place be that tangent would have crossed the x-axis? Let me add something to my little statement up here. Also, everywhere tangent of x had an asymptote, cotangent of x will cross the x-axis. Okay, so that is super helpful. So let's go back over here. All right, tangent crossed, had an asymptote at -pi over 2. And so it says that cotangent will cross the x-axis right there. Well, it also had an asymptote at pi over 2, so it will cross at pi over 2. It will cross the x-axis. So let's think about it like this. At -pi over 4, our tangent was +1. Cotangent will be the reciprocal of that. I'm sorry, it was -1. It will be the reciprocal of that, so it will be -1. Cotangent at, I need to go figure out what this one is to my left to finish this off. So -3 pi over 4, and then -pi. Okay, at -3 pi over 4, the cotangent is +1. And at pi, we would have another asymptote. So cotangent goes the other, sorry, that was supposed to go through that point, goes the other direction, because it's the reciprocal. Now it's asymptotes are definitely in different places, so make sure that you don't just flip it over and make it curve the other way. The asymptotes are in different places. Okay. Now it just repeats itself, so it will be this. It will have the same behavior on this side as it did over there. Okay. So if any of you are like, oh my gosh, I don't know where you got that the cotangent of negative pi over 4 is -1. I'm going to draw you a unit circle real quick. All right, negative pi over 4 is right here. Negative pi over 4 is right there. There is an ordered pair associated with that. I told you the unit circle was going to be super helpful for you. It is square root of 2 over 2 and negative square root of 2 over 2. All right. Cotangent of negative pi over 4 is x over y. So I take the square root of 2 over 2 and I put it over negative square root of 2 over 2, which is -1. Okay, so for any of you that are like, oh my gosh, I don't know how you got that cotangent, I use my unit circle. So the more you have it handy, the easier it is going to be for you. Okay, so let's notice some things about our cotangent. From here to here, from between my asymptotes, that is one cycle. So one period of cotangent is pi, just like tangent. All right. There is an x-intercept at the midpoint, at the middle of the the vertical asymptotes. All right. And so that will help us graphing it. So if you had multiple things, okay, like A, B, and C values, our A, absolute value of A, is still our amplitude. That has not changed. And cotangent also has asymptotes. We just saw that. The asymptotes for cotangent are still bx minus c, but this time it's going to be equal to 0 and equal to pi, because that's what the asymptotes are originally on the cotangent function. So, super important that you know how to find the asymptotes for cotangents. Let's graph a cotangent. Alright, so my amplitude here is absolute value of 3, which is 3. And now I need to know my asymptotes. Alright, well, bx minus c is 2x equal to 0, and 2x equal to pi. Okay, the little bx minus c equals 0, and the bx minus c equals pi, because that's where the original asymptotes were located. Solve each one of these for x. So I divide by 2 on both sides, I still get 0. Divide by 2 on both sides, and I get pi over 2. This is where there are asymptotes. All right, so let's draw. We know at 0 and at pi over 2, there are asymptotes. I'll draw my asymptotes in blue. All right, there are my asymptotes. Now I need to know some stuff that's going on in between. I know that halfway between I have an x-intercept. All right. Well, halfway between 0 and pi over 2, pi over 2 times a half would be pi over 4, for anybody that's not sure. All right. I also need to know the value halfway between there and halfway between there. Well, halfway between 0 and pi over 4, again, multiply pi over 4 times a half, and you get pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8. All right, so now I've got at least the x values labeled, okay? My amplitude is 3, so I'm going to go up to 3 and down to -3. And cotangent, remember, goes the opposite direction from tangent. So I would go all the way up here at 3, the x-intercept, and negative 3. And so here is my cotangent function. And there we go. And that's it. I feel like cotangent is quite a bit easier than sine and cosine. There's not quite as much work to do for those. Okay, now I told you that in order to do cosecant and secant, you really had to be able to do sine and cosine, and you're about to see why. All right, here's why. When you graph the cosecant of x, all right, we know a couple of things. All right, we know first of all that that is the reciprocal of sine. So, in order to graph the cosecant of x, it has asymptotes where y is equal to the sine of x crosses the x-axis, because they are reciprocals. All right, so when you flip it over, you would have 0 in the denominator, and so it would have an asymptote there. All right, for y equals the secant of x, we know that is the reciprocal of cosine, and so it is going to have asymptotes where y is equal to the cosine of x crosses the x-axis. Okay, and so every time you are asked to graph cosecant, you must graph y equals the sine first. Every time you're asked to graph y equals the secant, you must graph y equals the cosine first. Okay, that's the only way this is going to work. So if you don't know how to graph sine and cosine, you're not going to be able to graph cosecant and secant. Okay, so let's jump into graphing one of these. Let's start with, we'll do a cosecant. Okay, so what we're going to do is we are going to use the graph of y is equal to the sine of x plus pi over 4, okay, old news, section 5, to graph y is equal to the cosecant of the exact same thing. Now, the reason you're asked to do that is in order to graph cosecant, you must graph sine. So that's what we're going to do. We're going to graph the sine first. So, we have to go through all of our steps for graphing sine. All right. We know our amplitude is 1. We know our period is 2 pi over our b value, in this case is 1. And there is a phase shift because there is a c value. And so our phase shift is, remember, that's our c value, in this case is negative pi over 4, divided by our v value, which in this case is 1. So negative pi over 4. So what that means is that negative pi over 4 is the start of one cycle. That's our first x value. Okay, it's the start of one cycle, so that is our first x value. All right. Next thing I have to consider is those 5 key points. If we're starting at negative pi over 4, I need to know what am I going to count by. So I take the period and divide by 4, and I get pi over 2. Okay, and so this is what I'm counting by. All right, I'm counting by pi over 4. I'm starting at negative pi over 4. Okay. So let me sketch a little table. We are still working on sine, all right? So I'm going to write sine down here because that's what we're doing, is the sine. All right, so we're starting at negative pi over 4. We're counting by pi over 2, so we add pi over 2. When I do that, I get pi over 4. Add pi over 2, you get 3 pi over 4. Add pi over 2, you get 5 pi over 4. Add pi over 2, you get 7 pi over 4. And the reason that works out that way is I have to get a common denominator, so really every time I'm adding 2 pi over 4. So 1 pi over 4 plus 2 pi over 4 gives me 3 pi over 4. All right, so now I have my x values. My y values come from the sign of the original function is usually 0, 1, and my amplitude is 1, so that can stay 1, 0, negative 1, and 0. Now we are going to graph sine. Alright, we are graphing sine. So I've got my values put on my graph. Alright, I'm going to do the sign in black. So at negative pi over 4, I'm at 0. Pi over 4, I am at 1. 3 pi over 4 back to 0. 5 pi over 4, negative 1. And then 7 pi over 4 back to 0. Alright, so what we have here is this is y is equal to the sine. And so make sure you label. Alright, there's the sine function. Now we're going to be able to do the cosecant. So I told you that cosecant is going to have an asymptote everywhere that sine crossed the x-axis. Okay. So these blue lines are the asymptotes for cosecant, because that's where sine crossed the x-axis. All right, those are my asymptotes. Now from there, you know that cosecant and sine are reciprocals, which means you flip it over. All right, so this value at pi over 4, 1 does not change, but notice that between negative pi over 4 and 3 pi over 2 is an upside down, like a heel, okay, like an upside down U. Well, cosecant is going to go the other direction. So it looks like a U, and it doesn't touch the asymptote. Between the asymptotes 3 pi over 4 and 7 pi over 4, it has the same point at 5 pi over 4, and it looks like an upside down U. And so one cycle of cosecant is 2 curves. Okay, one cycle of cosecant is 2 curves, because if you'll notice, my sine, that one cycle of sine was that black curve. What's the same as the one cycle of cosecant? All right, so 2 full curves would be our full cycle. All right, and so to do secant, we would do the same thing, but you would start with a cosine graph, and I told you where the asymptotes would be, and it will have the same behavior. It will look like U's everywhere that cosine, it will flip over. Maximums and minimums become minimums. Maximums become minimums, minimums become maximums. And you would have 2 U's. So secant looks very similar to this. This is definitely something you're going to need to practice to try to get good at. And make sure you have your notes very close by. And that unit circle is also super helpful. Let me know if you have questions. I expect that you will. But I love to answer questions. That's why I do this. So let me know.